Okay.
Promising.
All right. I think it's right. Hi, everyone. Hello, everyone. Welcome back to another edition of the Perception Action Journal Club. I'm joined again by Marianne and Andrew. We're cracking on with the Turvey book. It's been a little while since the last one. We're summer after all. We got busy schedules, so we're doing chapter 13 and 14 today. Hi, guys. How are you doing?
Good. I'm just excited to discover I have in fact read the correct chapters.
You did enjoy them? These ones were too long. It was kind of nice. I just read them this morning. So again.
Yes, I'm hoping I can remember. I read them a little while ago, but I have my notes. I was just saying before we pressed record that I thought I'll sneak in a recap before 7. So
I quite enjoyed these ones, actually. I think
I did.
The skill acquisition people, here's a little tease. One, and I think understanding this really is key to understanding the difference between nonlinear and linear pedagogy. Why task decomposition doesn't work. And Turvey even talks about constraints at the end of the.
I know.
It defines it and talks about different types. So there's a lot of relevant things here. So.
Yeah, absolutely. When I saw the constraints show up, I was like, yes.
Yeah. There we go. We're getting closer to what people care about.
If you've held on this long, this is here's the reward.
So these two chapters, Turvey is getting us into Gestalt psychology.
Yes.
Right? And basically I think most people know Gestalt psychology started in Germany. Its most famous quote and line, if people know anything about Gestalt psychology, they know the phrase, "The whole is greater than the sum of the parts." Right? That's what Gestalt. The first chapter, I think Turvey's trying to lay out what they were railing against, right? Why people believe the whole was equal to the sum of the parts. That's what Turvey's trying to lay out. Any kind of overall thoughts and takeaways? I think there's lots of interesting stuff in here.
Yeah, there's a ton going on in here. Yeah. So we're coming out of the Helmholtz stuff.
Yeah.
And identifying the major influence of Helmholtz and the fact that Helmholtz was effectively working as hard as he possibly could to come up with a coherent implementation of psychology within that Cartesian framework, right? He's fully on the hook for everything, but he's decided he can solve all the problems. And Helmholtz is not the villain, because actually, Descartes' the villain, but Helmholtz is the main thing that, and his structuralism, right? The idea that the structure of psychology and the anatomy of the nervous system are where order comes from, is a thing that comes up in here. And so he's kind of the guy, he represents the camp that the Gestalt camp are going to be pushing against.
Yeah.
Even though ecological psychology and Gestalt are not the same, and quite importantly, quite different, they are fellow travelers.
Yeah, they're sympathetic to each other.
Yeah, there's definitely some sympathies and some overlap there.
Yeah, so Marianne?
What I picked up in that early bit is that structuralism and behaviorism were the two things around at that time, weren't they? That he's sort of kicking back against both of those. I did have to get my dictionary out again in this one, I remember. So I was quite happy with this sort of like idea of atomism, which he talks about, breaking everything down into small parts. But I wasn't familiar with antatomism, which is then focusing on understanding those small parts. And so a big key bit of this, I think, and behaviorism kind of does the same thing, isn't it? It's like if you can break something into small enough parts, you'll find the linear relationship.
Yeah, I think that's about I like that part too. I think this was all happening at the backdrop the same time as the start of neuroscience was really reporting. We could find that specific cells did specific things and it seemed to fit. And the idea of structure is that order comes from the anatomy. Right?
Yeah.
There's one example I thought of when I used to teach. I teach sensation and perception. I say if you compare the visual system and the auditory system, right? One of the reasons our visual systems are primary sense that we use for spatial perception to know things are, is because it seems like space is preserved throughout the entire visual system, right? On your retina, areas beside each other receive light from locations in space that are beside, and that's maintained in the midbrain, the LGN, and it's maintained in the visual cortex called retinotopic mapping.
Yeah.
So the perception of orderly space comes from the orderly anatomy, it seems like, versus your auditory system, everything comes to the same place, right? Your hole in your ear. So space is not preserved at all. There's no space in the auditory system.
That's true.
So you need to do work to get space back, right? Because the auditory system is organized by frequency.
Which is interesting, though, because as soon as you start thinking about it, we've got creatures that echolocate who are literally doing acoustic space perception. And so clearly it's possible, right? So again, like, this is some of the, when you go looking at the retina, you start finding all these problems with it, right? Like the idea that there's a lot of immediate problems and a lot of ecological objections that go all the way down to the idea that anatomy is not the thing that determines, right? Like, it goes back to that famous thing about Gibson 79. He spends 4 chapters talking about what's in the environment before he gets anywhere near the eye.
Yeah.
Because vision doesn't begin with the anatomy of the eye. It begins with what happens in the environment. Vision literally begins when light bounces off something. And so, that's another example of the push.
Yeah.
And all that preservation, all that topographical organization and things.
Is the difference, though, with humans, with us as a species, is that we haven't, as we've gone through our evolutionary pathway, we haven't used our ears as our primary source of visual perception, of space perception. So animals that do use sound have a completely different, like they've got big ears, like that there's a lot of other things, sounds they make that they use to rehear it, so that it's more complex than.
There is a lot of things. Yeah, animals that specialize in hearing definitely
have a very different auditory. Yeah.
But those anatomical things facilitate rather than dictate, right? So your big ear is just to be able to collect more sound waves, right, and be able to do things.
And be able to swivel them around like
and to move them in mobiles to scan the acoustic array effectively. And one of the other there's that whole cool field of literature of people being taught to echolocate.
Yeah.
Right. So all the blind people teaching themselves. Is that one guy? What's his?
The one that cycles.
Yeah.
I interviewed him. Yeah.
They
got a Mel Goodale.
It's amazing.
So again, it's like, we might not have obviously the ears for it, but we clearly have more capacity than we typically use. So
yeah, I think if Gibson was here, I think it will echo what you said. He would say the order is not from the anatomy, not from because it's in the environment. It's from the information. Yes. But there's perfectly good higher order information to localize sounds. For example, the time difference of arrival, the years, the intensity difference. You just have to, like you said, Mary, with experience, you can learn to pick up and educate your attention to those information sources.
Yeah.
But you're right, we don't have a huge need for it because we're visually dominant.
Yeah.
Normally sighted people. So So I think that's an anatomism.
That might get a little bit into the next chapter.
Words he introduces.
Yeah.
But again, if you think about it, how sensation perception is taught, right? You start with the retina, you start with the structure of the receptors, you start with the anatomy. I remember being taught and being very impressed by the fact that spatial organization is preserved all the way up into visual cortex, like retinotopic mapping. People were like, isn't it amazing? Like, look how well this stuff is preserved, right? And they're like, it's clearly an important foundation for everything else. Like, it's so important that it's being preserved with all this fidelity, right? And A, of course, it's a little bit more messy than that. But B, part of it is, again, it's like the Hubel and Wiesel experiments, finding line detectors and all that sort of stuff. And if you go measuring, if you ask the nervous system a question it can understand, it'll give you an answer. So if you ask it, can you detect a line? The visual system will go, yeah, I can detect a line. But that doesn't mean that it can only detect a line, right? Like, it's just because you actually, if you actually ask it, can you detect tau? then the brain goes, yeah, tau, no problem, right? Happy to detect tau straight away, for whatever. And so there's an interesting angle of one of the reasons why you find that topographical mapping in the cortex is because you went looking for it and you measured the response of the cortex in certain ways.
Yeah. Yeah, that's the fallacy of fMRI, like the subtraction method, right?
Yeah.
What it really when you measure brain activity, you're really the neuron you're looking at responds to whatever you're interested in and everything else.
Yes.
It just responds a little bit more to the thing you're measuring, line orientation or whatever, but it responds to everything. It's always active, right? So that's kind of the policy. But yeah, I thought that was interesting.
Is this the anatomism?
Yeah, the idea that structure, that's what people really ran with, I think, when neuroscience first took,
for a long.
The order comes from how our anatomy, how it's built, right? Our anatomy is built. That's the anatomism. The other one, Atomism, is the idea that information is carried through in unique substance.
And preserved. That there was. They didn't talk about things like myelination, but he was talked about the fact that a lot of these nerves are completely isolated. The billiard ball
example,
Was he implying, he didn't use the word connectionism, but I don't know, I was kind of getting a little bit that idea that there was a bit of an implication around connectionism, which I remember it's kind of dropped out, hasn't it, from like 30 years ago. So you've got these.
Yeah. Well, one of the big things is less connectionism, although related to it, and more associationism. So the idea that, each of these specific nerves is carrying these specific nerve energies, and one of your jobs is to learn to associate things together. So you
fill in their missing bits.
Yeah, and so association becomes a key principle of psychology, but then into neuroscience, right? You get talking about neurons that fire together, wire together, right? It's all about associated activity. Things that happen at the same time become connected. Things that occur in some proximity to one another become associated, and it's those. And you have people talking about building chains of association. Like that was the elements of different flavors of behaviorism. Exactly what the things were being associated. You could go quite simple, or you could go a bit more complex. So Toulmin, I think, was like more of a molar behaviorist, where you were allowed to associate higher order things, but it was all like you had to associate things and build up these chains in order to be able to know anything and be able to connect anything up. And I think, and connectionism isn't just associationism, but there's definitely an element of that to it, I think.
Yeah, because he doesn't use that terminology, but I got a sense of that.
They're definitely related, I think, although connectionism is a little bit more amenable to dynamical systems, I think.
Again, I was wondering whether there was there's like hints in some of I think, like you say, even in Helmholtz, they're trying to solve the problem and they get really close, but the constraints maybe of language and where they're at, they get stuck.
Yeah, the other thing I took out of it from you is they're beginning to get into the inadequacy of perception, the inadequacy of the information coming in. Right. Like the constancy problem. Like my perception of color or brightness or lightness, or whatever, it just depends on the reflection of information coming to my eye. Why don't you see my shirt as different when I walk out in bright sunlight versus in this room? And the more light's reflecting off of it, right? Did I change my shirt? Right? That's the concept. So we need we've created a problem for ourselves we have to solve, because the assumption we're making about what's coming in is creating inadequacy. Yeah. So
and that's the specific nerve energy stuff and all the kind of ideas. It's funny. It's a really static view of the nervous system as well.
Yeah, I was going to say it's all very static, isn't it? Because he's going to move away from the idea of like what he started with, like the man in the room observing a world, and the man's separated and static, and the world's separate and static, and it's one way, and all of that's going to go out the window, isn't it?
But like I was thinking about this as well because I remember one of the craziest things I saw during my PhD. I was taking an intro neuroscience class with Oliver Stearns, and just one of the craziest things he showed us was this real-time video of neurons reaching out to form connections and then pulling back in, and like the fact that this neuron was constantly changing shape, constantly changing and so like it's not wiring, like it's not.
Mm-hmm.
This is why structuralism really falls apart, is that like the brain is so dynamic, it has a stability, but it doesn't have a static structure to it, and it's so and at the level of the cells are just, like literally reaching out, making a connection, and then it's not that connection stays there and just isn't used, it's just that connection goes away, right? And all of that happens on a sort of a tens of hundreds of millisecond kind of time scale, right? So it's really funny to me with some, like, I don't know huge amounts about modern neuroscience, but I know bits and pieces about modern neuroscience, and it's really funny reading this stuff, and sort of the key assumptions are like, well, there's these wires, and it's really important that there are these wires that have this one job, and it's funny just how dumb that sounds now. But even if you're not an ecological type, that would sound dumb, I think.
What you're saying there, Andrew's making me think about the way in which we know our brain sort of changes that kind of behavior through different parts of our lifespan. So small children and then in teenage years, they are just reaching out and connecting to everything, aren't they? I mean, the brain's building connections. And if those connections then don't get used, so they're not being built for a purpose, they're just all being connected. And I know it's a bit simplistic, I'm being a bit simplistic here, but it's the ones that then stay and get used that then don't get pruned away later. So actually there is a time element, and that behavior is different within the brain and those connections during different times of our lifespan.
And it's also not that they're not being pruned, it's that in order to stay, they have to be actively maintained.
They have to be,
just go. There's a difference between, like, you can throw a wire out and the wire will stay there, and you don't have to actively maintain that wiring even if you don't use it. But as far as I know, in the nervous system, if it's not actively being used, it simply goes away, and it might show up and go away because that use lasted 500 milliseconds or whatever, and so that's the lifespan of that connection, right? And it's funny just to think of that, this seething mass of activity. This doesn't connect to any of it, right?
This gets nicely into then, I think that for me, the crux of this chapter, from what I remember, which he then goes into like really talk about what a machine is, how you would define a machine, and mechanistic processes.
Andrew would like this because he gets into what a mechanism
is. Go on, Andrew, you can get to this. It gets into this. Obviously that type of behavior would not fit.
I think that's a good segue. Like, he gives the example of a clock. And we originally I think the way I was taught neuroscience, like, you could build it like a clock. Like, we could identify this area in the brain, V4 does color perception, always, forever. That's what you can localize function, which obviously that goes against the principle of redundancy. Redundancy is the idea that you can switch out parts. Multiple parts can do the same job, right? You don't have to just do it with this one part. But yeah, I thought that was interesting too, man. Like I said, this gets into the non-linearity, linearity.
I think the practical, what a machine can and can't do and what it is. So it sort of starts to get a bit more practical, doesn't it?
So I am going to wave the flag for a modern mechanism talk.
Okay.
So I really think Turvey's really articulating what's going to be the ecological, and in this case also the Gestalt, objection to considering the organism as a machine that operates mechanically. And I'm all on board with that. I think that's totally fine. And again, I'll just kind of identified this before, and just to identify again that there's this notion of things being a machine that operate mechanically, and you get mechanistic explanations of those. That's one. All of that is one package. There is, in the philosophy of explanation literature, this neo-mechanist explanation where they're not so committed to biological systems being machines, that's they don't consider them to be machines in this kind of sense. They're moving, they're accepting the realities of modern biology and moving away from that Cartesian kind of analysis. But they're trying to make a distinction and argue about how to develop a mechanistic explanation of the activity of that system. And that mechanism, and it's a function of on parts and processes. And we talk about this, the fact that, if you have a machine, you can look at the parts separately, and the parts independently contribute to the function of the machine. And there is definitely an element of that in the mechanistic explanation literature, where you have to decompose systems and study the parts of them and localize properties to, so this bit does that thing and this bit does that thing. So you have to localize properties to various aspects of the mechanism. I do think that the modern mechanistic account is trying to find ways of explaining the activity of systems, and it's trying to front up to the realities of the complexity of those systems. So I don't think it's on the hook for all of this machine. But there is and I've written about this, and I still think that there's an ecological mechanistic approach that can be taken, I think. But all of this concern about where this gets you is very real, and it has to be taken seriously, because if you want to understand how a biological mechanism is operating, you can't just study the parts in isolation, because they don't just add up to, they don't just contribute their bits independent of everything else. We have impredicativity, we have loopiness, we have nonlinearity, we have all those things that are real concerns for developing these kinds of explanations. So, right. What am I saying? All I'm identifying is that all this banging on against mechanistic approaches and thinking of things as machines is real. It's important. It's a central feature of the ecological approach. It gets summed up in that slogan of the unit of analysis is the organism environment system, right? And that's really important. But also just to identify that it might still be the case that we can tell stories about how things really work, because there are pieces, right? And I'm not permanently connected to lots of things, right? I in fact am softly connected. I softly assemble things. I'm currently in one field of affordances. When I get up and go and do something else, I'll be in a different field of affordances. So there are pieces that you can identify that have properties that contribute to the function of the device, not in an entirely independent fashion, but also they do, affordances are, they're about what the world is offering. So it's just to flag up that it's quite complicated, but all this discipline about remembering that you just can't take the thing apart, look at the parts, put it back together and expect to have the story. That's really important.
Yeah, no, I think that's good. And I think there's, like I said, for skill acquisition purposes, so Turvey talks about the principle of superimposition.
Yes.
So he has a picture of a clock, right? And if we replace the word understand with train, there's a problem. So I can understand how a clock works by looking at the hour wheel, the minute wheel, the pendulum, through understanding what each of those parts do, because they add together to make the clock, right? So the skill acquisition problem is I can make the whole thing clockwork better by training by making the hour wheel better. I could pull it out, make it better, put more oil in it or whatever, train it and put it back in, and the whole clock will work better. Right?
Yeah.
And superimposition's pretty much the opposite of Gestalt, isn't it? That means that it can't be more than the sum of the parts. That's the opposite bit. The whole cannot be more than some of the parts, and it cannot exhibit a property that's not contained in the parts.
Yes,
I would say, I think superimposition means the whole is equal to the sum of the parts. You can just add them all together, right?
It says exactly that on page 195.
Opposite of Gestalt. Yeah.
So I think that's really important to understand this part. But
sorry.
I think your point
if superposition is impossible, then there's no impredicativity. For example, if you just have a set of things that you add up together and they do exactly what the sum of them would predict, then you can have such a system. That's why we have clocks, right? But it just turns out that that's not how electrical systems do anything at all.
I take your point, Anger. I think this chapter is arguing against hardwired machines.
And the
like
machine,
it's hard assembled. You're arguing that you can, if you take a softly assembled for a specific task, you can have some mechanistic type properties.
Yes,
and that goes across the whole system, including the environment, right? Yes. Yeah.
And some detail. Go on.
No, go.
I was going to say sometimes those small parts do matter. It's like I'm colorblind because some small parts missing, and you know the stuff that we talked about in the last chapter that we finished. You know the crazy things like eating live insects. So there are, but it's not a linear relationship like we talked about. There are sometimes those details do matter, but they matter because they maybe affect some kind of bifurcation point or phase transition, either preventing or enabling it. They are the legs of a table, so again more complex.
Yeah, but I keep thinking back to dynamical systems, right? So, you know, dynamical systems have both a composition and an organization. So their composition is what are the variables. And the variables are effectively the pieces required in your description of the system so that it does what the system does, right? And you need to have a variable for everything that matters in the actual thing you're studying, right? And then you've got that's the composition, what it's made of. Then you've got the organization. How are those variables arranged, right? Are they added together? Are they multiplying? Like what's the internal organization of that dynamic? And even if the thing of interest is the operation of the system as a whole, in our scientific analysis, and as we come to try and understand how the mechanism, why the mechanism does what it does, the fact that it's built of particular parts organized in a particular way matters, I think. And that, to me, has always been the essence of modern mechanistic goal. The mechanistic goal is not that everything is a machine. The goal is, no, can we make our explanations out of things that stand in for the real parts and processes of a mechanism, right? And so the fact that when I'm reaching to grasp something, like I'm made of some bits and not other bits.
Yeah.
And the bits that I'm made of, it's important that I'm made of certain bits and not other bits. And how the reaching and grasping goes depends on which bits I'm made of and which bits I'm not made of. So like, it seems to be the case that we want to be able to tell these stories about how the thing is actually happening. What are the actual pieces that have been brought together into an organism environment system and coupled through perception and action? And so even if the behavior itself, you have to study it in that context and all those we still want to tell a story about, well, there's an affordance over here and an effectivity here and some information here, and the information and the affordance are not the same. They're related and they're connected and they're impredicatively connected and et cetera, but they are not the same damn thing, right? So there's a distinction, I think, between what the organism is up to and what the scientist is up to. And that's quite important. And it's important that what the scientist is up to aligns as closely as possible with what the organism is up to, but also we have some other things, some other concerns as well that the organism doesn't have, and that's okay. So, anyway.
I think what else was in there? Yeah.
Then he gets back to that atomism. I think I pronounced that right. That information must travel through a substance, right?
Yes.
Which and going back again to my teaching, when I used to teach perception, I gloss over quickly. Light is maybe a wave, it's maybe a particle. We don't know. It has properties of both, right? But he brings in electrical and mechanical. We have to do we start assuming there's weird. People for a long time were trying to understand what the substance was that light traveled through the ether. Is there something in the air that light which was kind of a failure?
This is where he starts moving into the idea of fields.
Yes.
Yeah.
Fields are weird. Well, they're really weird because they are designed to replace substance ontologies, right? So, and There's something comforting and familiar about a substance ontology where something happens because something carried that information. I read a pop side book. I can't remember who, Brian Greene maybe, in which was talking a lot about fields because they're central to a lot of modern physics. And for about 10 minutes, I had it. And how they work and why they're interesting. For about 10 minutes, I was like, this is great. And then it all fell apart and I never got back again. But they are a really different way of thinking about how one thing can possibly come to affect another thing.
Yes. Yeah, it's moving away from there's comfort in the billiard ball analogy, right? I hit that ball, it moves and hits that ball, that hits that ball. I can it can be complicated, but I can understand it.
And it expands we'll talk about Markov blankets. No, it expands what we're looking at, doesn't it? It widens our field of analysis, what we include within that system.
Well, fields are an entirely different toolkit, as I understand it, to billiard balls and atoms and various things. Like, you can do things with fields that you can't do with these substances that enable you to solve a lot of complicated problems about cause and effect and how things happen and why things affect other things. This is why, I wish I could remember what that book was, because, like I say, I have just encountered the idea of what a revolutionary concept in physics the rigorous notion of fields was. Like, it was such a change. It was Turvey's talking about all the reliance on Cartesian-ness and, 21st century physics has changed and done X, Y. Fields, as I understand it, was one of the things that changed, that enabled 20th and late 20th century physics to be different and to do very qualitatively different kinds of things.
Can we get into those? But my knowledge base, I don't think, is particularly good, and maybe the analogies and the way I think of it, might be completely off. Actually, Andrew, I tended to think about them a little bit like something that actually changes. Well, it changes everything. So an early way of me thinking about it would be what would happen in a river if the river level went up. And I got this analogy. Actually, I spoke to a friend of mine many years ago. He was doing a PhD in Bangor looking at dopamine levels in the basal ganglia, and he said to me, it's not actually what's happening. This was like nearly 40 years ago, so I might have misremembered it, or it might not even be correct, so please don't quote me. But he's talking about it's not necessarily what's happening just within the synapses and stuff. He's going, it's not that simple. It's sometimes like the background amount of dopamine in the system then changes all of that. It's like something that encompasses the entire system. Now all those relationships change because the background flooding of dopamine is completely different. And I thought that's like a field. So something that is, whether it's electromagnet, it changes everything because it affects everything that's within that field, isn't it? Then all the relationships are changed.
Yeah, I think this is getting a little into the system level, right? So a field doesn't lie within an object.
It's the system.
It projects a field that interacts with other fields.
And it can change all the relationships. So something like the water level bit in, like you were saying, the dopamine, it changes all the features. It changes everything because the same features that were there before now have a completely different relationship because you've changed that background, you've changed something in the bigger system.
Yeah. Like, I think use magnets as an example, right?
Yeah.
Magnets and you put two magnets beside each other, it creates a field in between.
Yeah.
If you threw another magnet in there, or object in there, it would cause it to do something.
Yeah.
But it wouldn't do without that field.
By either one of the magnets. Yeah.
I'm with the juggalos on this one. I still don't know how magnetism works, right? Like,
it's very complicated.
And it's like it's so weird, right? But it's so central, and it just means that you don't need a particle going from one to another in order to have its effect. It's because these things are creating situations by virtue of the relations between them, such that things happen in certain ways. And it creates, you get fields have, it's related to, you have attractors and repellers. in fields, and you have a vector. Like we talk about vector fields, right, where you have wherever you are in relationship to the various attractors that sort of determines what you do next, right, depending on where you are in the field. The reason in the Gestalt chapter was that the Gestalt people got into fields. That's why this is showing up now.
Okay.
If you want to understand, one paper I would recommend if you want to get into this is Gibson has one of my favorite papers of all time, Gibson and Crooks.
Oh, yeah.
Theoretical field analysis of driving.
Yeah.
His idea was that as a driver, you project a field out of safe travel and where your car can go, and they all interact with each other like magnets. Mm-hmm. It's really brilliant. So I think for me, it helped me understand what. But Gibson was he loved this idea. He really latched onto it.
I think he starts having, he starts moving away from Gestalt pretty quick. I think he finds. I think he starts finding it fairly limiting in ways that bug him quite quickly. But he also, he was definitely, as I understand it, one of the early non-German adopters. Like he wasn't one of because one of them was at Cornell, I think, is the reason why Gibson knew about it. Koffler ends up at Cornell at some point and spends.
Did he influence Kaufman as well? Were they up there?
I don't know.
Yeah. The other thing that intrigued me about this idea of fields is I've never heard this term before, nature philosophy.
Yeah.
The idea that all fields can be reduced to the same thing, right? Whether it's electrical field, a force field, it's kind of the middle of 207. It says the important thesis is the major tenet nature if the right experimental conditions can be identified, then it should be possible to convert any one manifestation of force, light, heat, electricity, magnetism, gravity into the other.
Is he not getting into thermodynamics there?
I think it's to me this is going to be the explanation for kind of multisensory perception a little bit later on, right? That auditory fields and visual fields and they're all the same thing. They can all be converted because they're not specifically defined by their structure, the particles or the atomism. They're defined. Maybe I'm going way off on.
I missed that.
Yeah, but we're not really. Yeah. Then he gets the best. So you get the best the best section heading of my favorite, 14.2. Order arises from dynamics, not anatomy.
Yeah.
Yes. So they're moving away from the idea of anatomism that we've been going on against, and the idea that, but we're not. This is another place where we're going to attract people that are skill acquisition. We're getting into invariance here, right?
Right.
There's properties, there's laws, laws of dynamics that give rise to order in a system. It's not just complete chaos. I guess that's what,
Yeah.
I seem to remember that was a feature of Gestalt perception theories as well, was that there were kind of neural fields doing organizing work.
Mm-hmm.
I seem to remember that was related as well. But those fields weren't anatomically defined. They were functionally defined. Yeah.
He started
talking
about Faraday, though, didn't he, then, in the fields?
Yeah.
I've forgotten that bit.
And so the other thing just to flag up in that section is that Turvey's, again, flagging up that we're going to talk about some fairly complex dynamical stuff at some point. So names like Iberol, Haken are showing up again. Like those are going to be central.
We're getting into dynamic.
Yeah, we're getting into really
dynamical systems,
complex
dynamical systems to behavior. And they distinguishes between a machine like a clock and an organism on page 210. And we'll get all the things we talked about before, the lack of the what's that word? Impredicated. The idea that cause and loopiness, right? That's a good word, Andrew. I don't know if you made that one up, but the perception action loop is the loopiness of perception action, or what?
David Farouk uses loopy
Yeah, I like
a
it.
lot, doesn't he? That's a phrase, yeah. Yeah. And then we get into forces. Now, are they different from fields? Because the Faraday bit, they were talking about forces, weren't they? And how forces can figure under sets of constraints.
Well,
I might have to have a quick look.
I think part of it is, so as I understand it, forces in physics are conceptualized as what fields do, I think.
Yes.
Yeah, they were lit. Yeah.
So we experience fields in terms of forces, I think.
Yes.
So it's not that there's a force that's a thing in and of itself. It's all fields. It's fields all the way down in physics, as far as I can remember. And the force of gravity is what it's like to experience a gravitational field.
That's such a good. It's what we should have used.
Yeah,
actually.
I think that's what I was.
Again, it affects everything. So we take gravity away, everything behaves differently. Put gravity in, everything behaves differently with gravity, which is kind of what I was trying to explain. But
I think that's what I meant earlier. That all fields are effectively reducible to a force, whether it's gravity, magnets, right?
Yeah.
I think it's the other. I think all the forces are reducible to.
Yeah. That's a better way. Yeah.
And those forces affect everything within that force field and might change the relationships that they have with each other and things that would be there without it.
Faraday, I always think of from watching too much science fiction shows, Faraday cage, right?
I do as well, yeah.
Force,
lightning.
Field of forces that isolates.
Yeah.
If I remember correctly, right?
Hiding from lightning storms.
Exactly.
And a bunch of other stuff.
Trying to think what else was in that. We got into 14
There's a question about, he gets in. I don't know if I read this the wrong way. The idea of simulation, the machine as a.
So actually, we could say question.
Simulacrum.
Wasn't that the end of the last one? That Victorian scientists basically they thought that if they could build something, they could understand it. That's something.
Yes.
And if they could
model it, you could.
If they could model it, you could understand it. It was the birth of reductionism, I guess. That if you can break something into small enough parts and model it, you could understand it.
Yeah, So simulation is what a machine does. So this is. I took this. I don't know if I took this the wrong way. This is the kind of motivation for the eternal model, like a representation, right? The thing inside our head has to do this, simulate what's going on out there. That's what the job is, right? In our brain, we're trying to simulate the environment, like the world outside us. That's how we act and perceive, right?
Yeah.
I don't know if that's close.
Are either of you watching the comments? Sorry, I've just popped them on, actually. I thought we should be probably interacting. So
I just thought someone was asking about exactly this.
Yeah.
So it's funny.
That's why I brought it up. I saw.
It's funny because I was waving the flag earlier about there being a distinction between what Turvey is railing against in terms of mechanical machines versus neo-mechanist theories of explanation, but baked into even the neo-mechanist theories of explanation is this idea that your job as a scientist is to create a model that contains reference to real parts and processes and the real dynamics of the system. Why? So that you can simulate the operation of the mechanism, to poke around and explore it. You can run experiments that you can't do on the real mechanism, for example. So it's funny that there is still within that more interesting notion of explanation and what a mechanism can possibly be, there is still the goal of simulating and that being you're being able to simulate is part of you being able to say that you understand and can explain the operation of the system that you're studying.
And vital. That's what we do. And if we're coaching or, like I say, researching, we need, like having some model or some theory. It's that same kind of thing as we can simulate, which allows us to make decisions or think about things. Or
Yeah.
Let's see. What else we got? Then the last part of 14, we're getting into constraints.
Right.
To bring that. Where does Turvey?
And homokinetics. Do we get into homokinetics?
Yes.
So I'll have it. I always keep Turvey's a constraint is any condition that limits the motions, reduces the degrees of freedom of a dynamical system. Right. That's our.
That's a good quote. I did make a note to put that into my paper.
Yeah.
Although I'll flag up reason. I'm trying to remember. It might have been Vicente. There's at least one paper out there identifying that constraints can be not just limiting but enabling.
Enabling. That's true. Yeah.
And I admit that I have not read that paper in enough detail to know whether or not that makes any sense, because the notion of a constraint does seem to be, no, it's about limiting the motion so that it can only do some things out of all the possible things that it might possibly do. But yeah, I just want to flag up that there is a paper out there about constraints.
I've tried to talk about this. I think like a constraint not only like you could tie your hands, that takes away a movement solution, but no coach would use that, right? It also kind of pushes you in a certain direction, a good constraint. Like all exploration, it kind of channels you into a different area of solution space. I think that's kind of
something that's, I know we talk about rate limiters, but it's something that's, so they do seem to be negative, but in coaching, we'll try and use something that will make something more likely. That would be an enabling constraint. Yeah.
So it has,
and a field could be enabling.
Yeah. It kind of, I would agree with that. But I think it's hard. Like we're trying to get you to change by taking away your existence. That's what I think of constraints. We're taking away a movement solution.
Your pink envelope
on the task design, right? We're making it won't work anymore.
Would your idea of pink envelopes be an enabling constraint? I'm just trying to think that, like trying to make things more.
But then this part about different and anatomical versus non-integratable constraints. I thought I understood that, but I'm not 100% sure.
Right.
Oh, I thought I like the discussion. Then it gets into thermodynamics, open versus closed systems. I love the description of a plant, right? The idea that a plant actually is a closed open system because it both exchanges energy with its environment, also exchanges basically parts of itself.
Yeah.
It changes chemistry. The plant constructs itself. I love that phrase.
Yeah. How is this different then to autopoietic systems? Or are we talking about the same thing?
They might be the same thing. So I think
systems that maintain themselves.
So an open system is what you would call it if you're doing thermodynamics and physics. Autopoietic.
You'd call it in biology.
It might be. It's more biology and activism. Yeah, I think that. Well, if I had to guess, I'd say that all autopoietic systems are open systems, but not all open systems are
autopoietic. Okay.
That would be my guess there. So one's a type of the other one. Yeah. So, for example, he notes that, basically, we have to be talking about open systems because they're the only thing that enable impredicativity, perception, action, all those kinds of things. Yeah.
Mm-hmm. Thank you, Greg. They weren't my handrails, though. I think they were Holly Logan's. This got into a bit that I find fascinating, just from my interest in. I think I remember doing what was it called? It's an undergrad, evolutionary psychology, which I absolutely loved. because I like crossing species boundaries, obviously.
Yeah, that's why I flagged that up. I thought you would be. Yeah.
So, which is why that's always interested. And then he gets back into a bit of the epigenetics again. And then I love again, he then opens up the whole space-time thing, doesn't he? And talks about, let's get away from the man in the room as a system observing something. And does he know that what he's observing is what's actually out there?
Yeah.
So actually, it's not that simple. There are no linear systems. It's not top down. It's not DNA out. It's not evolution in one direction. So that's got right into stuff that I find fascinating.
Yeah, I love in the coda section. I love this. It gets into the kind of loopiness. Turvey's by the latter, the bridge between organism as observer, measurer, or controller, and environment as observed, measured, or controlled is fundamentally a matter of lawfulness at nature's ecological scale. To detect information is to perceive the behavioral relevant dimensions, measures of environment and body, and the strategy controls for relating environment and body in the satisfaction of intents. A lot of stuff there, but that's essentially perception action.
Yeah.
Right.
Coupling.
The coupling.
Yeah.
Right? Can't separate the measurement from the or a lot of going in a lot of other areas, uncertainty principle,
So
physics and
I was just trying to think about what these chapters are doing in terms of the progression of the lectures. And these lectures are they're kind of serving as the bridge from we've spent all this time engaging with the Cartesian program, the various implementations of the Cartesian program, peaking with Helmholtz. And now we're just starting to get to the point where I think part of what he's just identifying is that it's not just Gibson who was mad about this, right? Like other people are starting to push back against this and to have real deep concerns about those programs. And one of those programs that had deep concerns was the Gestalt school. And one of their solutions was to, and they had, this is why ecological psychology and Gestalt are at least sort of fellow travelers. And so, because the concerns that we had were motivated from very similar kinds of places. Gestalt went one direction. They got very excited about fields, and everything was a field. And but they were trying to tell a story about how one thing could have an influence on the behavior of another thing, without telling these kind of atomist stories that were connected to anatomy and structure and all that sort of stuff. And so there's at least a step in the right direction here. For the first time, there's a step away from the Cartesian program. Actually, this is the first encounter we've come across with anybody doing anything qualitatively different, as opposed to just coming up with a different flavor or fundamentally the same program. So it's been quite interesting just going through these chapters, and it's given Turvey the excuse to talk about what a machine is and to identify, actually, no, everyone's pretty happy that biological systems that we're interested in are not machines because they can do the kinds of things that machines don't do. And then to think about, well, okay, if they're not machines and they're not working with, they're not passing forces around using these, how are they working? Well, you can start talking about things like fields and more complicated, more interesting notions of cause and effect. And it's right. He's flagging up that the ecological solution is going to involve a whole bunch of other moving pieces, organizational, the overall stuff, informational, all the things that Gestalt doesn't have. But I was just noticing that for the first time in this book, we're not doing Descartes anymore.
Yes. He leaves Descartes behind, doesn't he, when he says the whole thing of his thesis was that everything could be, if you understood whether to break it down into little bits and then
and we're starting
art to perception.
And the way in which Gestalts went about doing things provides us with some clues about the things we're going to have to do in order to break away from just doing Descartes again. We're going to have to stop. We're going to have to talk about causation in a different way. We're going to have to stop thinking about things as machines. We're going to have to stop thinking about things as the results of linear chains of cause and effect, and and also that there are some options, right? That some people have already been thinking about how to break away from this. I don't know whether the Gestalt guys, I think they seem to be pretty purposefully kicking against the Cartesian kind of program.
Yeah. I like the one thing, Turvey's doing a good job, I think, the appeal to you, Marianne, like that this is an explanation we have to have that works for everything, right?
Yes.
We're not going to have a special
one
mechanism
for Homo
just
sapien.
human beings. We're not going to propose. We have to explain everything. That's what dynamical systems is, right? Explain everything, any system, an animal, plant, human, whatever. Yeah. So he sprinkles that in nicely, I think, here.
Yeah.
But yeah, I think you're right. We went from Descartes to Helmholtz. He got us to perception with the Descartes being to Helmholtz. Now he's going Helmholtz to Gestalt.
Yeah.
Yeah. And we still got a couple. The next chapter at least is still a Gestalt, right?
Yeah. There was I had to get my dictionary out for holonomic. Is that how you pronounce it?
Oh yeah, to do with laws.
He was talking about laws and systems. I didn't, and I'm still holding on to that because then we moved into more epigenetics, and I was like, I can't quite get the link yet. How did he do that? He snuck from one to the other. But I think it's because actually he was talking about thermodynamics, wasn't he? And was there a hint at the end of it that he's talking about that's a law that has to be followed. It cannot be broken. And then we get into the idea of entropy, and how does entropy lead to more complex, bigger systems, because they would seem to be negentropic, which made me think I'm really glad I read Julia's book.
Turvey, one of the last major projects that Turvey was working on was with what's his name? Swenson, and Claudia Corello as well, I think, was involved. They were doing non-animal intelligence, so they were looking at plant stuff. But one of the reasons they were doing that was they were doing it in the broader context of, and Swenson and Turvey have a couple of papers, their explicit motivation is to try and derive perception and action as a natural consequence of the laws of thermodynamics, right? Why? Because that's where the rubber meets the road. Laws of thermodynamics, like in flows of energy and all that kind of stuff. Basically, like, you know, if perception action is going to work, it's got to work in that context. And it's funny, I think, and it really was kind of the ultimate expression of Turvey's conviction that all of this should be grounded in a very physics kind of sense. But there's pushback on this, right? So there's people who are like, well, no, physics is the wrong place to go. You know, we're biological systems and we don't want to be grounded to physics because physics has caused all these problems in the past. So you get Tony Chimera, you get Rob Whithagen, you get people who are explicitly trying to ground it in evolution and development and biology instead. And there was a paper recently about pluralism in ecological psychology and about that being a good thing. And they identify 3 flavors of ecological psychology. And there's Turvey's physics kind of psychology. There's Tony's sort of biology kind of ecological psychology. And then there's, I think it was connected mostly to Heft as sort of social ecological psychology. I have mixed feelings about exactly how useful that paper is, but it was identifying that these were potentially up to different projects, right? And one of the things that's happening is that, like, it's Turvey's really fully all in on connecting all of this to physics. And not everyone thinks that that's going to get us everywhere we want to go, and that might be true.
He's laying it out.
What was the ecological? What's the? I do have the book.
Okay.
The Introduction to Ecological Psychology. So Julia Blau and Jeffrey Wegman's book. They talk about that at the end there. That
So they're primarily grinding through a easier version of this. Primarily.
Yeah, I think so. Yeah.
At the end, they're nodding to the fact that the field has diversified, which I think is a healthy thing for our text.
Yeah, for sure.
Yeah. But they get into the thermodynamics and the grinding it in that law of entropy, and how to satisfy the fact that we're getting more complex because more complex life forms, and how to explain that from an entropy perspective that's not entropic.
Yeah.
Which was
good stuff. I think
really
good. We got one more chapter in Gestalt, and then we're going to take our. So we're moving towards ecological psychology, then we're going to take a hard right turn to computational and representational approaches.
Yeah.
Okay, we're not quite there yet.
Can we just before we get there? I think do you remember? There was a bit that I really liked. Again, they were looking at evolution. Remember, a couple of conversations ago, we talked about those different timescales of learning, and we've got the individual learning within a lifespan, and that sort of like learning in terms of co-adapting to an environmental niche as a species. And I think he starts to get into that towards the end of this chapter, doesn't he? He starts talking about a bit more about genetics and how it's not just this one-way relationship,
Right.
but that behavior and lifespans influence DNA, influence genes, not just we have this more complex interactive relationship.
Yes.
I can see yours.
No,
next time I'll have to join the chat.
Yeah.
I've only just managed to. That's the.
Right.
I was trying to log in while we were talking about something.
Yeah.
Sorry.
Those for listening, I am reading.
Relevant,
But this, I think, this starts to get us into self-organization. That's what I'm getting at. So he starts looking at self-organization over multiple timescales, over a bigger.
That is mentioned somewhere here. I can't remember.
Oh, absolutely. Well, because it's a thing that machines can do, for example.
It's a thing that machines can't do. And that's where he kind of finishes, from what I remember, where he finishes this chapter.
Yeah.
He basically opens the box, doesn't he, completely, and just says, like, we've got... which he hinted at before around time and space, that he was going to do that. And again, he does that at the end of this chapter.
Yeah. We're getting there. Like I said, we're going to take a little detour for a while again, but
it has been interesting. Like these chapters were an interesting opportunity to talk about some things that are much more explicitly talking about introducing some of the steps you're going to have to take in order to be ecological rather than Cartesian, right? It was interesting to have the excuse to start introducing some of these concepts, and because it's also quite important to identify. Like Gibson had a lot of these insights and developed obviously developed all these things in great detail, but he wasn't operating in a vacuum, right? There is a sense in which ecological psychology is kind of the first really well-worked theory of perception that completely and fundamentally purposefully rejects the Cartesian approach. But also, he was that Gestalt was there to provide inspiration and ideas and collaboration, right, in the form of, developing the field model of driving and talking to, I think it was Kafka who ended up at Cornell. So again, the early 20th century was clearly a time when these things for the first time were starting to be really challenged. And presumably that's connected to quantum theory becoming a thing, right? People were starting to get into quantum theory and realizing that it was breaking every single rule that physics had been obeying for 300 years. There was clearly an instability had been introduced into the system, right? So there was space now potentially for a phase transition to do something else, right? Where previously there had not been, right? That's the other thing I really took away from the first half of this book is just everybody was there's all these different theories of perception, and fundamentally they're not different. They're just different implementations of exactly the same underlying program. And I think that's been one of the really interesting things.
That used to, before they were at that time, if you think about, the environment that they were in and constraints that they were under in terms of language and what had gone before, that they seem to be, or to me, they seem to be all trying to get to the same place, but they're still highly constrained.
Yeah. And the thing is, they were constrained by something they thought was true.
Yes.
They weren't, Helmholtz wasn't an idiot. He was convinced by all of the many arguments that this was the best way to go about studying these systems, right? And people have put a lot of work into that.
I think you said on the last one, didn't you, Andrew, about the thing with Gibson was that he didn't try and work out what was, how to solve. He just basically, when he got stuck, he
Yes.
was able to just go, okay, let's go somewhere else completely, rather than try and work out how to solve that little small bit.
Yeah. It's a lesson in how powerful your core assumptions are, right? It's something that you question them, and they kind of lead you in certain directions. But yeah, no, I like this chapter a lot. I think the field. I just thought another place where fields will come up a lot again is like optic flow field, right? When you move through the environment, you create this field of information around you, not just a single. It's not just a single object or event. You create this whole field, and how that field changes and deforms as you move.
Right.
It tells you a lot about how fast you're going, what direction you're going, whether you're going straight or curve, right? So, yeah.
And
so I think that's an important concept.
Yeah. I also was thinking again, looking back at the sort of like the things that we maybe don't perceive and pick up as human beings. As we move around, we're changing magnetic fields to organisms that are sensitive to them that we might not be. Having spent a long time, training search and rescue dogs, air scenting search and rescue dogs, and learning about how they scent, because basically there's bits of our dead skin cells falling off us all the time. So if we could see those, there are these fields of smelly dead skin cells falling off us everywhere. If we stand still long enough, we make a big pool of them. That is those. They're kind of like fields. So as we're moving around, we're actually influencing our environment in ways that maybe we can't perceive, but other organisms can. That changes some of those fields as well. So sometimes for me, it's quite interesting to think about those bits. They might not be relevant to us as people unless we get lost and we want to be found by a dog, and then it does matter, or we're handling one. But there are other things like that happening at scales that we may not be aware of. So these fields are not just big, but also microscopic fields.
Yeah, absolutely.
Yeah. No. Cool, guys. So I think we'll wrap it up there, guys. We're almost done part 1 of the book. Woo! Third way through.
And I've enjoyed them more and more. They're definitely getting into the.
I like these 2 ones.
I did.
I can connect them to more things. That's, I think, hopefully relevant to people listening. Although some people like the hardcore stuff too, but
I felt like I had to really work hard at the first 7 chapters.
I talked to some coaches that read, sports coaches that read this book. I like, oh, wow. I'm not sure what you can get specifically applicable out of it, but you'll understand. It's useful, I think. So we'll keep cracking on. We'll not sure when the next one will be, but we'll figure it out later on. So thanks, everyone.
Cool.
Thank you. Good to see you.
Bye.